Okay, we continue with the database design methodology. So in database design methodology, there are three phases that you need to go through in order to design the database. The three phases are conceptual database design, logical, and physical design. So this is actually the formally approach that we're going to go through in order to design the database from step by using step by step. So in conceptual design, let me understand what it means that conceptual design here. This is actually the process. Conceptual design is the process of design the model of the database without define or without thing or link to any physical consideration or no. I mean, we don't think this model will tailor to any particular data model or DMS. So we built this conceptual representation of the database by define what actually the entities, the relationship, and the attribute involved. So by doing this, by presenting this, we will have a very general design of database. As we say, it's a conceptual that actually finally conceptual can be implemented in any kind of database model or DBMS. Of course, the design concept reflect to the what we call this global view of the entire database, and of course by the entire organization. Right? And when we finish the conceptual, so from conceptual we need to transform the design to the logical. So what means logical here? Logical is also it's a process of a design where by using the conceptual, right, the logical design will actually focus to the particular data model. That is very important. So I mean that in local design, we need to choose what kind of data model that we need to use. Right? Of course, at this moment, we still independent to the particular database system or mean the particular DBMS. Particular to Oracle, for example, particular to Microsoft SQL. So not yet. In logical design, we just design according to relational, for example, or network database or hierarchy database, right? So this is actually in logical design, it's a logic to the data model, right? Of course, there's a process to translate from the conceptual to the logical that we will go this further later, right? And lastly, before we can create our database, we need to transform the logical design to the physical design. Physical design is a process to only to define the description of the implementation of database in our machine system, I mean our server, that we call the secondary storage. So we describe what actually the final base relation, the detail how to implement the database in terms of the file organization, indexing, and how to access data, how to create the table, and what kind of storage that we will use, and many other things regard to the database implementation. And of course, this physical design, we already determine what kind of database system we want to use. Oracle, for example, so I mean the physical design is already toward to the Oracle implementation or other database also. So this is actually the overview of database design from the conceptual, logical, and physical. There are steps. Step 1 we consider is conceptual, step 2 logical, and step 3 regarding to translation logical data model for the target DBMS, and the rest, step 4 and the rest is regard to the physical implementations, right? So this one we will discuss later. in conceptual design, this actually we have to look into one by one the step. So, okay, we start with the identify the entity type. So, what is an entity type? Is the entity is actually the data or the object that you want to store as a data. So I mean the entity can be the thing that you can see or the thing that you cannot see. This is actually a concept. For example, like staff, we can see staff or we can see student. It can be an entity or the thing that we cannot see. For example, like transaction, that very general term, and recommendation, for example, this not the thing that you can see, but there can be a concept in our database, right? So according to Connolly, entity type, entity is something in we can identify in requirement specification. Is referred to the word noun, for example. Noun in our specification can be established as the entity. So you must identify entity, then entity, we will explain how we represent the entity later in terms of the design, but entity will represent the data that you want to capture. And then of course entity itself is not enough, so we will define later what actually the characteristics of the entities that we talk about the attribute later. And then of course when you identify entity, so the next step you need to identify the relationship between the entity and entity. Normally the relationship exists between two entities. So it's possible to have more than one entity, more than two entities, right? Can have also have a relationship, but it is quite rare in terms of the normal design, but it's possible to have. So relationship here, so we refer to the binary kind of relationship. So the third step is regard to the identify the attribute belong to the entity. So attribute associated to the entity is actually represent the characteristic of that entity. So by determining the attribute, so we can know what mean by the entity itself, right? So the entity also have a relationship with identity, and relationship between the entity also is possible have a attribute. So this might happen according to what kind of the relationship that we will identify or we will go through later. So when you finish identifying the attribute, you also need to determine the attribute domain. This is step number 4. So we will determine the domain of the attribute. What mean domain here? Domain is actually regard to the kind of attribute, the value or the type. What kind of the attribute is that? What the value, what the format, and what is actually the type of the. So we need also need to define in the conceptual model. So after that, of course, when you know the entity, so you need to determine what kind of the key. What mean the key here actually represent the attribute. By understand the attribute will determine the uniqueness of the entity itself. So in conceptual, we just need to define the primary key or other key that we call alternate key. So at the conceptual level, this good enough for us to identify this. Alternate key, because it's possible you have more than one key that like metric number and identification number. Both can be a primary key, but we cannot choose both as a primary key. So we determine this in conceptual, and later the next step is possible to apply some of the what we call is enhanced modeling of database design. So some process or some method in enhanced modeling is possible to be applied here. It depends to the requirement of our database. So what is a kind of the modeling here? Example such as specialization or generalization and aggregation and composition. This actually what we call is another variant of a relationship from the normal relationship that we will discuss later. So is a possible have, is a possible not have. So that's why it's actually it's optional step here. The next task is actually, of course, when you have the model, you have the database model, you need to check. Okay, of course, it's possible exist the redundancy relationship or redundancy happen in your model. So we need to check what means redundancy here. So relationship between two entities possibly have two-way to link. I mean that in this case we need try to make the relationship only one. So we try to avoid to have more than one relationship, but doesn't mean that it's not okay. Sometimes we need redundant relationship, but normal case we don't want that. So we do checking here. There are a way to do that, and after that, when you finish this task, so you need to validate the conceptual model against the user transaction. There are some way to do this. We need to go to the user and let the user check the correctness of the validity of our model, and this also done with the review with the user to our conceptual model, to make sure that our model is acceptable and can be used to create our database later. So this process will be this iteration process. It's not one flow. It's possible many flow until you get the final design for your database. So this is example of the some of the example of the conceptual data model by using the ER diagram. So we will explain what mean ER, entity relationship diagram. We will discuss it. So this example of the one piece of the design of the DreamHome. You can see there are staff linked to property for rent, and property for rent linked to the client also linked to staff, and property for rent is linked to the owner. So you can see the entity and some of the attribute represent the primary key there, and there are kind of relationship. Yeah, there are, you can see there are one to many, one to one, and also there are a kind of enhanced model, generalization and specialization. So I will discuss this detail about this later. Okay, when you finish this task, you need to create the model, and there are some example of the model that when we finish to design this, like this, right? So you can see the first cut, or the what we call the view of the DreamHome with enhanced model. They already have the one-to-one relationship, one-to-many relationship, and also the generalization and specialization model. So finally, in your conceptual, you you must have this kind of model. That will be your conceptual, your final conceptual, before you go to the logical design. And there are 3 ways to check the model for redundancy. First, examine one-to-one relationship, remove redundant relationship, and consider time dimension. So in example of the removable redundancy, you can see here there are example of the relationship between a client and property for rent, and client through lease. So there are 2 ways in order to get information about the client lease property for rent. So we can get through relationship between client, lease, and property for rent, and client to the property for rent. So there are 2 ways to do, and this case look like they're redundant. So in this case, we can consider there are no important relationship between client to property for rent. So we can remove it because it's not important, because a client and property for rent, we need to know what information about the lease. So in lease, we can see, we can know the lease number and the lease date, for example. So this is more important. So we don't need the relationship between the client and property for rent, where this actually not exactly fill the requirement of the user. So another one, another example of the non-redundancy, where this case we need that kind of redundancy, because the example, man married woman, woman mother of child, is we need this relationship because the situation in this case, man possible married to the woman, and sometimes it's not possible to marry that woman. Even it's not married to a woman, they maybe have a child. So this why this redundant required, because the possibility happening here. So this example of the how redundant need to use, right? So basically redundancy is not good, so we try to avoid the redundancy relationship, but in some cases redundancy is required. So what kind of the situation required? So you can see this example of this. So after that, you go to the next step to check the model, support user transaction. So in user transaction, there are 2 ways to do the checking, by using describing transaction and using the transaction pathway. So this is actually the method for you to check the possibility of the transaction, right? So this method to make sure that your design support the requirement, support the information required by the users. So by doing this, we can see the design, the entity that we design always can produce the information required by the user. So in this figure, by using this pathway to check the conceptual model, so you can see the example of the requirement represented by the number A, B, C, and until the end. Is actually, you can refer this from the Connolly book at the appendix 1. So you can see how the requirement and how the entity that we define can support the information required. And the last one, of course, in order to make sure that the design is good and to fulfill the requirement, we need to ask the user to make sure this actually comply to the user requirement. So the rest, just want you to read about what is actually the critical success factor for database design. So please read and try to understand it. Thank you.